give the main point quickly, and that is things are changing really rapidly in AI and in space technology, and our civilization is becoming more dependent on computers and the programs that make decisions, and those are being used for space technology that we use every day, from navigation to communication to weather prediction, but also for space exploration. And we're going back to the moon in probably this decade. And one of the weird things about predicting the future is that most of the things like artificial intelligence or going to the moon or fusion has always been 10, 20, 30, 40, 50 years away, and it always is. And now we can't say that anymore. So AI is here and is making huge advances, and a lot of decisions are being made in terms of space exploration using new machine learning and artificial intelligence techniques, so we can do things that we couldn't do before. So this is the punchline. If you blink, things will change. We're in 2023, and this was 2001 Space Odyssey. So think about 20 years from now, we'll actually have people living on the moon. We'll probably actually have people living on Mars, and we'll probably all be Ubering autonomous taxis or something as we become more and more of Internet of Things and smart connected cities. But things really move quickly. So in terms of space exploration, as we develop robots to do a lot of the exploration, they have to have their own smarts, because they have to make a lot of decisions as they're exploring caves and lava tubes on the moon and Mars. And so we're developing a lot of the tools that are being integrated into autonomous vehicles and drones and airplanes and satellites, but also rovers. So a lot of things are going on. This is a famous chart of Moore's law, and it extends up to 2030, which seems so far away, but it's essentially been an exponential growth. Those are log plots of essentially the power of computers as a function of time. And essentially by 2030, we'll have more transistors per area than we have neurons in the human brain. We'll have more robots operating on Earth than there are humans. And so things are taking off. And so we've made a transition. As of last year, if you see a video on YouTube or on Twitter, you don't know if it's real anymore. Deepfakes have taken off, or if you Google something and you get a result, you now don't know if somebody wrote it or if it was written by machine language. So we've made that transition, and it's only going to get worse. But satellites, has anybody used a satellite today? So in your phone, there's a supercomputer. It's about a third generation Cray processor on your phone. It has a whole bunch of sensors: magnetometers, barometers, thermometers, gyroscopes, accelerometers. It has 4 antennae, right? Bluetooth, Wi-Fi, GPS, and the cellular network, all in your hands or your pocket. And so in 10 years, who's going to put Galaxy and Apple out of business? And what will be the platform instead of a smartphone? Google Glass, or will we start having connections? But what's going to make it possible are these types of satellites. The one at the top is a GPS satellite to allow us to figure out where we're going. And soon we'll have blue dots for indoor navigation. And this is a Starlink satellite that will provide global Wi-Fi everywhere for everyone from your cell phone or your Google Glass. And things are going. So exponential growth, if there's one piece of math that you learn about exponential growth. And so if you're young, put $500 in your Roth IRA now, and you will thank me when you're 65. Because exponential growth is essentially, can slowly grow, but as you get more and more money each year, you get more and more money. So have you heard the expression, $1 million is a really easy to make? It's the first 10 million that's hard, right? Because if you have $100 and you make 10% interest in 1 year, how much money do you have after 1 year? $10. If you have $10 million, how much interest at 10% do you make in 1 year? $1 million, right? So add exponential growth as the base number gets bigger and bigger. Each year changes bigger and bigger. And so this is the number of patent filings through last year in terms of artificial intelligence. It is just taking off. This little hockey stick diagram is not the global temperatures or CO2. This is the number of things launched into space. And we've had a low number with 7-ish% growth for a while. And just in the last few years, we're now launching thousands of satellites into orbit each year. And that's essentially Starlink. So Elon Musk's SpaceX Starlink. And Elon is building Starlink to raise enough money so he can get people to Mars. So he's hoping to get tens or hundreds of billions of dollars of revenue from your Wi-Fi on your phone with this global internet service. And he's planning to launch about 30,000 satellites in the next decade. So another dot. So everybody's seen WALL-E, the Disney cartoon. But each dot here represents a satellite in orbit around Earth. And there are thousands and thousands of these, and they're getting denser and denser. But these are the communications and navigation satellites that we have. And you can geosynchronous orbit is where we get our able to watch the World Cup or whatever you want anywhere on Earth, essentially instantaneously. And Arthur C. Clarke wrote a paper in the late 1940s that predicted that if you had 3 satellites in geosynchronous orbit, you could have global instantaneous communication. So Arthur C. Clarke, the 2001 author, actually predicted global communication, space-based communication. So, as I said, we're going to the moon. Artemis just announced its crew for Artemis 2. They're going to have the first crew since the Apollo era to go out to the moon and come back. About a year or so later, there's going to be Artemis 3, where we'll have the first woman and the next man to set foot on the surface of the moon. And then it's supposed to be continuous and have a quasi-permanent presence on the moon and use that to go to Mars. So all of the early robots, and Jeff Bezos' Blue Origins was just selected this week for a lunar lander on the moon. But we'll be going there, and a lot of the control systems, navigation and exploration are going to be with augmented reality and artificial intelligence to get there. So I just wanted to introduce you to the world of space, and happy to take questions on the future of space exploration. Or
yeah, so I can kick off the questions here, and then let you load up questions, and I'll run around with the mic. So Mark, what can we still learn from space travel that will affect our lives here on Earth?
So we all use space technologies right now, from your navigation and communication services. So we've become a spacefaring civilization, and if you are younger than 23, we've had a permanent human presence in space, International Space Station, and that's going to continue. And we're continuing to learn not only about the universe, but also about how we can use space technology to actually help us here on Earth, either better weather prediction, climate mitigation, adaptation, remote sensing, security.
You brought up Elon Musk and Jeff Bezos, so we're in an age now where celebrities are traveling into space, and we're seeing a growth in private space travel. Do you see this as helpful to space research, or is it a bit of a distraction, or maybe somewhere in the middle?
I'm a big fan of commercial space. If there was a Hilton or even a Howard Johnson orbiting space station, that would be great. If you're not my age, you probably don't remember Pan Am, but they were able to make predictions about routine space travel. And one of the things that commercial space can do that NASA's and ESA's and JAXA's of the world cannot do is take a lot of risks. So to go to Mars right now, we can do it. The technology is possible. One of the limits is human physiology and biology, the radiation, and we don't like low gravity or microgravity, and we don't like vacuums, and we don't like things moving really fast that can puncture us. But if you're a commercial space company, you can get astronauts to sign up for one-way trips to Mars. Would anybody do it right now? One-way trip to Mars? So a few people, and eventually a lot of people would do it. Who was the first person on the moon? Neil Armstrong. How would you like to be someone that an audience in a movie theater 60 years from now knows your name, right? I mean, be the first. And so I bet you commercial astronauts beat government astronauts.
So we're over 50 years since the moon landing. And then you mentioned there's the exponential growth, and now we're finally looking at traveling to Mars. Do you see that exponential growth going in such a way that within the next 50 years, are we going to Jupiter as well, do you think?
Sure. Jupiter's very cool. Not only has monoliths that can bring you into a wormhole, but it also has moons that have liquid water oceans. And what's interesting about liquid water here on Earth is wherever we find liquid water on Earth, we find life. And so there's liquid water oceans on the moons orbiting Jupiter. So the question is, are there Europa tuna fish or merpeople or krill? And so we're going to go. And so it's in NASA speak no earlier than, but we should have a lander on Europa no earlier than the mid to late 2030s. And ESA just launched JUICE, the Jupiter Icy Moon mission, and NASA is going to launch next year Europa Clipper that's going to go over and find landing spots.
Anyone have questions? Raise your hand. I'll run around the mic. All right, yeah. I'm going to go here first, but while he's talking, I'll be looking around for the next question. So be on the lookout. First question.
Hi. There's been a lot of talk about how this movie has contributed to the art of film, but how has it contributed to the talk about space travel?
Yeah, one of the things I love about science fiction is that the human imagination is wild, and we can imagine all types of things. They imagined a Zoom teleconference with your kid. Who knew? They should have. Right? I mean, there's all these things that you can imagine, and if you can imagine it, then scientists and engineers can create it. And so this type of movie, if you were looking closely, a lot of the Arthur C. Clarke ideas in terms of, we don't like microgravity, so let's have a big rotating cylinder to give you some centripetal acceleration to give you artificial gravity. And communication, recognizing that there's long delays. The speed of light is very fast, about 8 minutes for 1 astronomical unit, which is the distance between the sun and the Earth. And Jupiter's 5 astronomical units away. So it's many tens of minutes in one-way light travel, and trying to figure out how to do that. So science fiction, and it's hard to believe, but I think 76 was New Hope for Star Wars. So just 8 years after this came out, and if you saw some of the big space station, boy, that looked like a deck of a Death Star in terms of the architecture. So a lot of ideas, I'm sure, actually will come into play into our big orbiting space stations.
All right, we're over here now.
Yeah, so I guess keeping people alive in a place where they're not usually supposed to be alive, like on the moon or on Mars, it'd probably be quite expensive. Yeah, I don't know, just by the nature of space travel in general being expensive, but especially like permanent habitation on other planets. Like, do you think that there's some sort of economic incentive for people to invest into projects like this, or do you think that there is a possibility of like funding being achieved just by people wanting to go to space, I guess?
Yep, it's very expensive. It's about $1 million a kilogram to get something to the surface of the moon. So next time you grab a liter bottle of water, that would take $1 million to get it to the moon. So if you're going to go live there for a while, you're going to need a lot of liters of water. So a lot of the exploration right now is looking for water on the moon. And one of the good things we know, there's water on the moon. There's water on Mars. And one of the nice things about having it there is you don't have to bring it with you. You can just dig up the ice. And the other thing about water, it's H2O, so I can use sunlight to break that apart, and I have oxygen. So I don't have to bring my oxygen with me. And hydrogen and oxygen can be recombined, and that's rocket fuel. So I can get back. So there's a lot of resource utilization. And the regolith or dirt, I can mix it with material and use the water that's local to make cement. So I can start building infrastructure without thinking about having to bring everything. So there's a lot of ways we can make it cheaper. There are some economic arguments on why we should go to the moon. A lot of them don't actually make too much economic sense. But we're human. We evolved curious about what's over the next mountain, what's over that next ocean. And Carl Sagan's Pale Blue Dot, his thesis was as soon as we realized that Earth is this spaceship that has finite resources here on Earth, we've been yearning to get off. And to keep our species evolving, you know, are we going to see another millennia? How about 10,000 years? Is 100,000 years of human history possible? Who knows? But if it is, we're going to be getting off. And so I think that's going to be a lot of the drivers.
We're all the way back here now.
Hi. Around the time of the movie 2001, scientists envisioned artificial intelligence as being encoded in engrams, that artificial intelligence would be biologically lifted. My question is, how does artificial intelligence as it exists now differ from that conception? And is there a limit on the current way that, the current capacity of artificial intelligence?
A lot of the early work in code are called neural networks, essentially ways to try to mimic the storage and decision-making in biological systems. And right now, there's been a huge advance in image recognition. So image recognition is, if I have a picture of a cat, I can tell it's a cat. But there's a lot of different cats, or a truck. Is it a pickup truck? Is it a semi-truck? Is it from behind? Is it from above? We can figure it out, but computers are really not that smart. But all of the competition for image recognition, which now is skimming everybody's Facebook posts to know who you are, use essentially convolution neural nets or deep neural nets. And so we're still thinking biologically on how the human brain processes. There's tons and tons of different statistical methods that also try to mimic biological systems in terms of that branching and decision making. So it's moving really quickly, but biological mimicry in terms of structures as well as the way we think is still one of the dominant ways of conceptualizing artificial intelligence. We're still grappling with, are we there yet for deep or general AI? Are machines sentient? Can they think on their own? And there was a paper recently that was posted by Microsoft researchers suggesting that we're there, but you still can get laughed at in the computer science realm if you make that suggestion, but people are doing it now.
All right, the center here.
My friend sent me a question. He wanted to know if personalizing AI to a crew member, AI to assist in extravehicular activities would be useful, or if there's any interest in that. He wanted to specifically know about things like giving pathfinder directions or troubleshooting during space station EVAs.
Yeah, if you have enough data, sort of the big data revolution, you can learn a lot. And so there can be circumstances that we would be looking through manuals and even trying to extrapolate to a condition we haven't seen before. That could be possible for AI, and you would like to be able to do it. One of the reasons people argue we need to have humans on the moon or Mars is that if you're a rover, even with a lot of smarts, but you're a wheeled rover and there's a 1 meter trench in front of you, you're going to have to figure out how to get across or go around, where a human astronaut would do that, right? And so we're very adaptable. We can do things that we're not necessarily designed for. We can improvise quite a bit. And so that's one of the problems with computer code and some type of algorithm, is that it's as good as you could program it. And so the idea of trying to get more and more data, more and more possibilities, the better you are. And so that's machine learning, which as you get more data, you learn to adapt. So again, similar to the human learning, as I see it, I can then adapt my control systems. But I don't know about naming AI as a person that becomes creepy.
Right in the center.
Professor, there's been a lot of talk recently, articles about, the more scary aspects of AI, and some are referring to it as godlike AI, or there's talk about how AI isn't aligned with human values or human interests. Could you comment specifically about, say, the alignment portion of that? And it kind of runs counter to those people, like you said, who would laugh at some of the advances that Microsoft claimed at. And sorry, I don't mean to be too technical, but
Yep.
you get my idea.
Yeah, that's one of the problems right now, I think, with the advance in AI. It's happening so rapidly, we haven't yet figured out what's going on, and so we don't actually have ethical guidelines on what should be done. And so as we're developing more autonomous drones and all types of things. You could imagine them being used for security or military, and then taking a human out of the loop and making a lethal decision. So those types of issues can happen. And if anybody's played with ChatGPT or Bard or Bing, you know they lie, right? Because we lie. And so they'll make stuff up because we make stuff up. And so how ethical is it to say I'm going to develop an autonomous vehicle that's going to run around Ann Arbor? What are the guidelines on if I see a kid run across the street, do I go into oncoming traffic so I don't hit the kid? Do I hop up on the sidewalk? Do I run into the tree? Somebody's going to have to make that decision. Somebody's going to code it. And what should that ethics be? And so I think a lot of the AI community are saying, whoa, things are happening. ChatGPT 4, was only a month or two past 3, right? I mean, things are happening so quickly, and the advances are coming that we can start thinking about using it in medical diagnostic decisions. What if they're wrong, right? So all of these types of ethical dilemmas. So I'm a proponent of tapping the brakes and having conversations and ethical guardrails. And if you've been following any of the congressional hearings of the different OpenAI and such, they're all for it as well, because they would like to have some guidance before it sort of goes out wild in the internet.
Go ahead and ask your question.
Yep.
Earlier you touched on how NASA might be sending rockets to Jupiter's moon soon. How long do you think it'll be before they start sending rockets with people in them out of the solar system?
Great. Yep. So to get to Mars is about a 3-year trip, round trip. It takes about 7 to 9 months to get there. And then we use what's a low energy orbit. We essentially launch from Earth and we rendezvous with Mars when it's on the other side of the sun. So essentially you go into orbit around the sun. And so that's why it's a long journey. And then we have to wait essentially a year or so before we get back into alignment to launch, and a year back. So it's a 3-year mission. And so Mars is 1.5 astronomical units from the sun. So we're 1. So it's half the distance between the Earth and the sun farther away. And Jupiter's 5. So 10 times farther away. So the time it takes to get to Jupiter is years. And so as you're thinking about, let's send a crew of 5 people. So imagine getting in a Winnebago with 4 of your best friends, and you're gonna take everything you need for the next 6 years and stay in that Winnebago. And no McDonald's, no Home Depot, no emergency room, everything you need. So your iPod, or iPod, your music thing better have some good music tunes. So it's just going to be really tough. And Jupiter is a really harsh environment. Once you get there, there's a lot of radiation around it. Hundreds, thousands of times more lethal than the radiation in the Earth's radiation belts, the Van Allen radiation belts. And since it's 5 times farther away, the amount of sunlight is 25 times less. So it's cold and a lot of radiation and far away. So I don't think we'll be sending humans to Jupiter anytime soon, but we're going back to the moon, and we're going to figure out how to work in harsh environments, in cramped quarters, in a radiation, and so then we're going to go to Mars, and we're going to figure out how to do it there. So perhaps you'll be an astronaut on Mars designing the next exploration ship to go farther out into the solar system. There is a mission on the drawing boards right now called Interstellar Probe, and it's the first multi-generational science and engineering mission NASA's thinking about, because the time it would take is about 50 years, so the people who are working on it now won't be alive when it actually gets there. So this is the first time where the succession planning of how do you train the next set of engineers and scientists to continue that mission is happening. So we're starting to think long term, but it's always running into the annual appropriations issues.
Hi, thank you. I really appreciate this. On the slide you had before, you showed all the things flying around the Earth, and I was just thinking how that as a society, a global society, we've been able to mismanage Mother Earth with all the trash and pollution. What kind of space trash management program is going on?
So this orbital debris is actually a problem, and we've had several satellites accidentally run into other satellites, and when they smash, they make a whole bunch of more debris. We've also had 3 anti-satellite missile tests that were successful. The Chinese, the Russians, and the US, big space debris. It's all against the UN charter, but there's a lot of effort right now on trying to figure out how to minimize orbital debris. Currently, if you launch something into orbit, low Earth orbit, you need to make sure that it re-enters Earth and burns up within 25 years. That's the limit. And the FAA, the Federal Aviation Administration, which is in charge of this stuff, just has a rule that they posted for comment to reduce that 25-year to 5-year to try to clean things up. And there are a number of companies that are developing nets and rendezvous things, little CubeSats that can go attach themselves to big things to help them deorbit and all types of things to try to prevent it. One of the problems, though, with a visualization like this, it's not to scale. There's, a satellite is tens of centimeters to maybe 10 meters, and this is tens of millions of cubic kilometers. So the probability of running into something is relatively small, but it's getting more and more likely because you're typically in the same type of orbits. And the big concern is the International Space Station, and now the Chinese space station, because they have humans on board, and so they have to constantly monitor if there's things that might cross their path.
Hey, Professor. I was wondering if there were an actual very strong magnetic field object buried under the surface of the moon, if we would have found it by now, or if we would very soon, going back to the moon with all the harvest.
So a couple of the lunar missions, even the early Apollo missions, had magnetometers, and that was a planted question. I build magnetometers, and so we have some maps of the lunar's remnant magnetic field. It doesn't have a magnetic field like the Earth, so your compass points north, but it has a remnant field. There's areas of high magnetism, similar to Mars, has remnant magnetic fields, but almost all of these are from orbit, and so there could be magnetic field regions that we haven't yet observed, and that's part of the new lunar exploration ideas. As we're sending more and more landers, rovers, and astronauts, are there ways that we can essentially throw connected experiments out to do geophysical things, and including magnetometers to measure the magnetic field. And we should probably name any anomaly after Kubrick or Arthur C. Clarke.
All right, we have time for a couple more questions. I have a question here, and then I'll come down front to the handouts up there.
Yeah, so we did just watch 2001: A Space Odyssey, and I think the main philosophical conclusion from that is the potential for like AI, like general intelligence, to rebel against humanity. It was like a theme throughout science fiction, I guess. And I guess my question is a few parts, but like I feel like a lot of the discourse around AI regulation is as if it were just another technology. Like the analogy with Moore's law, for example, is just like a regular acceleration of technology, or and I mean, I think that kind of makes sense when you're looking at like single-use AI, that even something like ChatGPT, which seems like approaching human intelligence, I guess you could say, at writing essays or generating linguistic responses, but it doesn't do like the wide range of tasks that a human does. But if the Microsoft researchers are suggesting that we're approaching some form of general intelligence, and we are going to take seriously the idea, whatever this might mean, of like an AI exceeding the intelligence of a human, and therefore not being able to be regulated, I guess my question is like, should we, on an existential level, be pursuing this research? And basically I think that like a lot of this gets cast aside as like a joke, like this will never actually happen, but because we are actually approaching that, or whether or not we are, like just the fact that we could be approaching that level of AI intelligence without regulation or understanding, because like we can't completely understand the behavior of a neural net, for example, other than just observing its behavior, like inputs and outputs. Anyway, that's basically my question. Should we be pursuing this research at all?
Yeah, very multi-leveled and important question for society to be asking. And there's essentially technology optimists and pessimists. So one of a technology optimist is not worried about the future because climate change, we'll figure it out technologically, we'll solve it. Healthcare, we'll cure cancer, whatever it is, right? We're always been getting smarter and smarter and better. Just wait till Moore's law to catch up, right? And so the pessimist is, it's not inevitable that we always increase or use the technology for the intended purposes. And there are evil people in the world thinking of bad things to do. And so if we have any ability to control having those ethical guidelines, we should. And in research, we do. I mean, there's an entire group at the University of Michigan that thinks about the ethical use of research, either in terms of human subjects or animal care or whatever it is. But we don't yet have a societal discussion on are there things we should not be looking at and exploring until we have a better handle on what we'll do when we get there.
All right, this will be a final audience question.
Final audience question. Hi, Dr. Moldwin. A very much non-implanted question, as we'll see in a moment. So I'm glad that this is up again. First question is, what are those red dots in a line? And second, you mentioned that Artemis 3 has a woman and a man on it, and are they like already chosen?
So the red dots, we're looking at the Earth from just above the ecliptic plane or the equatorial plane, and those are operational geosynchronous satellites. And so Arthur C. Clarke, he said if I put 3 of them, so the speed of light is really fast. It can go around the equator of the Earth 7 times in 1 second. So it can go around the Earth faster than I could spin my finger 7 times a second. So to go the 24,000 miles to geosynchronous, or 30,000, it takes a fraction of a second. And then it can, so we're here in Ann Arbor, we can send it to this satellite, it sends it to the one over Europe and then down, or it can send it to the one over Europe, that's then over to Asia and then down, and we can have global instantaneous communication under a second. And so that's what those are. And geosynchronous orbit has a orbital period of 24 hours. So from the perspective of the Earth, even though it's orbiting, we're rotating once every 24 hours. So it appears to always be stationary above us, so I don't have to track it. So that's what's really cool about geostationary orbit. And then your second question? Remind me. Oh, Artemis 3, yeah. So Artemis 1 just went off, and it had the mannequin and Snoopy and a sheep, and it just went around the moon. Artemis 2, the crew was just selected in early April, and Christina Koch will be the first woman to go to the moon, and she's from Grand Rapids, Michigan. They're going to have the first astronaut of color going to the moon. They're not going to select the next crew until after Artemis 2, but they've already promised that there will be at least one woman, and people advocate, why not an all-woman crew? Great.
All right, so yeah, before we bid farewell here, Mark, where can people go to learn more about your work or learn more about the Michigan Space Consortium?
Google, of course. You can just Google Moldwin, and my webpage will open up, or Michigan NASA. You will get to our webpage, and we have a lot of, maybe not anymore, Michigan NASA, and you'll find the space grant. And it has funding for students, as well as faculty, as well as community members that are doing any type of STEAM engagement, so including the arts and humanities.
All right, everyone, please help me thank Mark here. And thank you so